Welcome to TMC 2021 Online. This session, like many others, has been pre-recorded and is available on demand. Parking brakes best practice. Welcome to TMC 2021 and an often controversial subject, but not necessarily simple. For this session, we have three speakers who will each focus on a different aspect relating to parking outcomes. Our three speakers are, firstly, David Hine. David is the Chain of Responsibility Manager at Coca-Cola Europacific Partners. Before joining Coca-Cola, David worked in government, retail and steel sectors, where he developed specialist expertise in load restraint review and certification, chain of responsibility policy development, and safety system coaching. Our second speaker will be Shayne Commons. Shayne is the product manager for Volvo Trucks Australia. And in this role, Shayne is responsible for managing Volvo's product offering to ensure market suitability and is the project manager for commercial readiness projects. As a qualified heavy vehicle technician with a background in Volvo National Technical Support, Shayne has strong experience in diagnostic support and quality assurance and has worked for the Volvo Group for 13 years. Our last speaker will be Craig Day. Craig has worked at Patersons Transport in the Narrandera since 2014 in the areas of driving and compliance in the workshop. Craig is a member of the ATA's Industry Technical Council of some 25 years and is well versed in supply chain management, logistics and compliance. And an aside to that, he's my partner in crime in a flying school. So I have a fair bit to do with Craig. With our introductions now complete, I will hand to our first speaker, David Hine. Over to you, David.
Thanks, Bob, and welcome everyone to the session. Today, I'm just going to talk about the risk and assessing the risk around park brakes and what best practice looks like. And this is really from a viewpoint of being, I guess, a customer of freight and people coming onto our sites who we may not be able to control all the risks. So let's run through what that looks like and a couple of examples. And these are industry examples that have happened over the last couple of years, but they're pretty straightforward. And you can see the risk straight away here, not only to the driver, but also to people who interact around the vehicle. So you can see a lot of these are pretty straightforward. Trucks moving uncontrolled during loading, during uncoupling, during unloading, and the impacts that can cause or poses the risk to people. And here's another example of what can potentially not only happen on your site or my site, but also happen to the general public when things go wrong. Unfortunately, these things have occurred and potentially will occur if we don't address the risk. So what's a simple solution in all those problems or all those incidents? Simple solution, sack the driver. We don't have a problem. Unfortunately, that's not correct. And if it was that easy, then we would never have a problem because no one would ever make a mistake. And that's the key part. People make mistakes, and it's about understanding that people will always make error. We are human, we make them constantly, and sometimes we don't even know we're making them. But a lot of the time, they're insignificant, our mistakes that we make. But at certain points, like applying a park brake, they can become very significant and become one of those things that is always going to be potential to either harm someone or kill someone. If you take a look at these quotes, pretty straightforward in terms of what we say. Mistakes arise directly from the way our mind handles information. So it may be a case where we're actually distracted with what we're doing. It's not an intentional thing. We may be distracted through the information. We'd either be turn up to a site, thinking of our next route, thinking of what's going on at home. It's definitely not through any stupidity or carelessness. And the second one, we must also design systems and manage systems to sustain error, which are either error through just normal error like above, or whether it's a violation. So the error is not is intended. So the driver just gets out of the truck and doesn't apply the handbrake because they're used to doing that. There may be changes involved of why that occurs. So if I look at it from a very simple risk profile and management, we talked about hazards, and the hazards in this case is the truck. So that's the thing that's going to hurt us or potentially hurt us. 9 times out of 10, the truck's a benign hazard and doesn't hurt us and doesn't move, and it's quite stable. But if we have a look at the process there around uncontrolled truck movements, what sort of things do we need to put in place? So what controls do we need to put in place to prevent an uncontrolled truck movement? So it's pretty simple. The driver gets out or doesn't get out. He applies the handbrake before any incident occurs. So it's very reliant on a single person of doing the right thing. And that's our current, I guess, single control that we have, single human control. In this case, the truck rolls off, which is the incident. It's a pretty alarming incident, so that the truck has actually moved. And potential consequences, we don't have anything stopping in that truck once it starts to move. The potential consequences is truck damage, property damage, and potentially, and unfortunately, in some cases, we've seen fatality. Now, if I look at it from the next perspective and what things we look to put in place, and especially from my point of view when I've got trucks coming onto my site, I'm looking for the same hazards there, the same control around the truck driver, the truck driver to apply the parkway. However, you see the incident has now changed. It's a much lower level incident. The truck doesn't need to be moving. I've classed the incident here as the truck doesn't have a park brake applied. So therefore, we're looking at it at an earlier stage. It's still a hazard. And if I look at my recovery measures to prevent that incident becoming, having some dire consequences, I look at a park brake alarm and the driver then applying the park brake because that alarm's gone off. Now that's it's a pretty simple thing. We're still relying on the driver to apply the park brake. They can choose to ignore the park brake alarm or may not hear it, which was some of the case in some of the incidents before. However, it's a much better, much more robust risk management profile of what we have there than what we had in the first one. And then by looking at the third situation, which is probably the ideal situation, is we eliminate the incident altogether. So the truck comes on, we're looking at potentially of an uncontrolled truck movement. The driver, again, applies the park brake. However, there may be an occasion where he forgets or they forget. And in this case, if we have an automatic park brake alarm, or sorry, an automatic park brake application, the control prevent the incident from ever occurring. We don't have the opportunity for that truck to roll off. We don't have a situation where the truck may be parked without a park brake alarm, a park brake applied. So if I look from those very basic things around risk management, these are the things that I like to see when the trucks come onto my site. Ideally, we're in a situation where we have more, we're not relying on the driver to not make a mistake. We're actually relying on a system and a process that's backed up, potentially with a more adequate way of actually eliminating the incident altogether. Just give you a quick example of what a system looks like, or what the real cost of what an incident may do. If you have a look down the left-hand side there, there's a number of, in this case, there's a number of things that this driver had a great experience, had 0 incidents, was well trained, had a number of years of experience. However, we didn't quite understand that he'd also suffered a recent traumatic incident. And if I go back to that first or second slide where I talk about terminating drivers or sacking the driver because he's made a single mistake, that loss to your business, that loss of knowledge, that loss of experience is straight away and can lead on to other effects in your business. It doesn't really solve the problem. However, if you look at it from a system point of view, you'd say, well, people make mistakes. We accept that. It wasn't intentional. We didn't support that person by having a better system that would eliminate the incident. So we didn't have an automatic handbrake or park brake alarm or a park brake. And the vehicle wasn't fitted with an alarm. So we didn't give that person an opportunity to rectify their mistake. So therefore, I'd say the root cause was actually we didn't supply an adequate system. And therefore, one of the choices could be simple apply park brake alarm. Who's responsible? And this is often the case. Me as a consigner or working for consigners, I often get asked, well, why are you mandating different things? And a lot of the time is I shouldn't be. It should be a collective of people who should be applying these things. So under the work health and safety laws, people with management or control over a workplace, so that's me, have a responsibility, but also people who manage and control plant, and plant being the truck, also have a responsibility. And also the designers and manufacturers and importers also have a responsibility to make sure that's safe. So ideally, I don't ask for or don't mandate park brake alarms when you come onto my site. You've already got them. You're already telling me that you're a safe operator. You're working in a safe, your vehicle and your plant is safe when it comes onto my site, and we're not endangering other people with the risk of a rollaway. Bob, back to you.
Interesting, David. And like you say, it's often too easy to say we'll get rid of the driver when in fact it's the system. And unfortunately, systems fail when processes aren't followed. So it's something that people need to keep in mind to keep the system functioning the way we all want it to function in a safe and effective manner. Our next speaker is Shayne, so I'll hand over to you, Shayne.
Thanks, Bob. Hello, everyone, and thank you. So today I'll be discussing Volvo parking brake system, the operation and functionality, as well as some of the safety systems and how some of those safety systems work. So to move straight into it, the Volvo system within the heavy-duty vehicles, the park brake control has been electronically controlled since 2013. So what this means is we're able to use that electronically controlled parking brake to provide the possibility to enable functions such as both manual and automated activation and release of the parking brake, but then also system triggers as well. So because the park brake control is electronic, we have possibilities for those auto triggers. And for example, one of those auto triggers is as simple as turn the key off and the park brake applies. So I'll go into some of those auto triggers and some more systems that use those triggers to activate the park brake within the next few slides. But that is a very good oversight or first step to understanding that the trigger is that first item is key off and the park brake applies. So the tractor and trailer within this system can be parked gradually. So if we apply the park brake lever to a certain, whether it's slightly or all the way past the point of the notch, or past the click, we can gradually apply the park brake on the truck and trailer. So this will automatically release if you're above speeds of 7 kilometers an hour, or if you're under speeds of 7 kilometers an hour, it will start that activation of the park brake process. If we look at the red circle here, that is the park brake lever within the display or within the instrument panel, and then the picture on the right-hand side there, that picture indicates the air production module and the lever itself. So the lever functionality, there's a few functions there that you can see in that picture. So if you push the lever towards the dash, we get a disengage of the park brake, and then if you pull the lever towards yourself, it'll go past the click or the notch, and that'll be the park brake application. So you might ask yourself, what happens if that lever has a failure, or it doesn't function, or there's loss of communication through the LIN connection from the lever to the air production module? Well, we have, like a lot of the Volvo systems, we have a fail-safe and safety systems to ensure that there is indication to the driver that there's been a lever failure, but then also systems in place to be able to overcome that, to be able to get the vehicle to a workshop for diagnosis. So what happens if you have a lever failure? You have a visual and audio warning. So the visual will be a visual signal within the instrument cluster, but then also the red LED indication within the park brake lever will be flashing while driving, and then it'll be followed by an audible tone as well. To be able to activate and deactivate the park brake, it'll be through those automatic triggers. So at speeds below 7 kilometers an hour, it will start to automatically apply the park brake. And then if you wish to take off and disengage the park brake, it will do that through the accelerator pedal. It will require slightly more torque to disengage the park brake. However, you put your foot on the accelerator slightly more, and then it will disengage the park brake for you to be able to drive off. But we recommend, if you are in this situation, you should take the vehicle to the dealership to get diagnosed at the next convenience. So next, the park brake system, and to give you a bit of an understanding of the Volvo park brake system, it is a system that doesn't have an air tank within that system, so a little bit different to conventional type systems that have the park brake air tank for residual braking and things. This is all controlled through the air production module, which is the dryer, the controller, and the distributor for the air to the different circuits, and including the park brake circuit. So for a moment, if we forget about all the triggers, being automatic, manual, and system triggers for park brake application, the APM, or the air production module, takes all these signals and then uses those inputs and delivers those signals to the EBS ECU, so the electronic braking system ECU, which then manages those signals and circuits to then be able to activate and deactivate the service brakes and the park brakes for anti-compounding. The anti-compounding function prevents the simultaneous application of the service brake and parking brake, so that we don't get in heavy load situations that will affect and then ultimately may damage the braking mechanism. So that's what we're trying to overcome there by having that anti-compounding to allow proper function of the park brake and not damage any systems. So if we look at this system overall, the air production module, or the APM, is really the brains of the system and the control of the system. So while in the driving state, the spring brakes are constantly pressurized by the APM, and the APM is what supplies the whole circuit with air. So next is one of the safety systems that I wanted to bring up today, is one that is available and standard on all our heavy duty vehicles, is the auto park brake apply with door open. So, and most recently with the introduction of the heavy duty range, or the new heavy duty range which happened this year, is now we've got the additional safety feature and implementation of the horn reminder as well. So at speeds below 2 kilometers an hour, if you open the driver's door or the passenger door, the park brake will apply. And then when the horn will sound in the brief period until the park brake does apply. So that additional feature there is to ensure that the park brake is applied. And if for whatever reason it doesn't apply, the horn reminder will be there to notify the driver that the park brake has not applied. The park brake activation with door open system will not work if the vehicle has no electrical power. I'll talk about electrical power in the next slide, but I want to leave this slide to say that this functionality is not to be used as the primary activation method of the park brake. It's very easy to use this as a primary activation method, as you just open the door and the park brake applies. So part of the reason for the introduction with the horn reminder as well is not just as a added safety feature, but also as a driver deterrent to use this as an everyday primary activation method, because drivers, and not just drivers, anyone that could become complacent with this feature and use this feature day in, day out on a Volvo, but then may jump into another vehicle that doesn't have this feature and then get into a situation of a rollaway or even worse. So this is the reason why we've got the horn as a mandatory requirement now, and something that's an added safety feature and a driver deterrent. So I said I'd talk about loss of electrical power. Since the introduction of the electronically controlled park brake, we've got numerous questions around loss of electrical power and what effect that has on the parking brake and the activation of the park brake. So what we have is the sequence of events to have a full loss of electrical power. Because of the fail-safes and the automatic application of the park brake, it's very unlikely to have a full power loss situation. Meaning that if we lose our batteries, or the batteries are isolated and removed from the vehicle, if running, will be running on alternator power and vice versa. So in that situation, you're able to turn the key off and the park brake will apply, or you're able to perform the normal park brake sequence, and then that will be avoided. However, on the next slide, we talk about isolation switches. So third-party isolation switches, which are essentially designed to cut full electrical power, can result in the situation of not being able to apply the park brake. So to solve this, or to overcome this, there's really two means and two ways of doing it. So we have a feature that's called brake and park, which is built into our bodybuilder module. So what we have there is the possibility to add a signal wire from the isolation switch to the bodybuilder module, which will then, when activated, will apply the brake and park feature, which will start the shutdown sequence, which then has a retardation level for the parking brake application of 3 meters per 2 seconds. And then once down to 1 kilometer an hour, it'll automatically apply the park brake. So then the second safety feature, or second measure that we can put in place to overcome isolation switches and the full cut of electrical power, or loss of electrical power, is what we call pneumatic emergency park brake switch. So we've got a picture here on the lower right-hand side, which is essentially a rocker switch that's designed to apply the park brake in the event of electrical loss situation. So this is standard on dangerous goods vehicles, where it is most likely isolation switches will be installed, and is an option that we can install on any other model as well. So this can be activated in any situation. You can activate it with the engine running, but you will get a park brake malfunction warning in the dash, because it is operating the air production module through the incorrect method, or a different method of originally applying the park brake. So what happens is, it comes up electrical park brake malfunction because you're evacuating the air from the APM to apply the park brake. Additionally, we have Roadtrain park brake valves. So our system uses a variant that we call TR Brake 2, which drives the introduction of the trailer control modulator and trailer relay valve, which simultaneously parks the truck and trailer, which is a requirement for ADR 3803. So we have some customers requesting temporary release of the trailer brakes in certain circumstances, and a lot of that is in regards to operating or loading of the trailers and charging the trailer air system. So the feature enables the operator to control the release of the trailer brakes in those situations of specific loading. So to apply the park brake lever, what we can do is the spring toggle return will disengage the trailer park brakes, and then we're able to reapply the trailer park brakes by either pushing the red button next to the rocker switch, or by pushing or pulling the lever of the park brake. So this is one feature that particularly Roadtrain applications can charge trailer sets without actually having to release the truck park brake as well. Next, throughout all this, obviously maintenance is a big key, a big part in the braking system as well. So we need means of activating a park brake service mode. With all the safety features and additional features built into the vehicles, obviously we've got all these things to overcome the leaving the park brake disengaged. So now we have a park brake service mode. So to disengage the automatic application of the park brake, what you do is depress or hold the lever while turning the key into the 0 position, and this will engage the park brake service mode. To disengage, you either apply the park brake through the normal means of the lever, or if you exceed 30 kilometers an hour, this will disengage the park brake service mode. So what I wanted to say is, even though we have several systems and devices to aid the driver and ensure that we have the park brake, or ensure the park brake is applied in any situation, I want to just say that it is the driver's responsibility to ensure the park brake symbol in the dash is lit up, and the lever, the light on the lever is lit up to make sure the park brake is engaged. And really the best practice is to apply the park brake through the lever, not through any of these other means of additional parking. So really thank you for the time to listen today and learn about the Volvo park brake system. So I'll hand it back over to you now, Bob.
Thanks, Shayne. A great overview of the technology that's being provided to us in modern trucks. David has provided us with the process of how we manage it through system control and processes. Shayne has given us a good overview of technologies, but the operator experience says that there's still things that can go wrong. So I'm going to hand now to Craig for him to give us a bit of an overview of experiences of an operator. Over to you. Thanks, Craig.
Thank you, Bob, and thank you, David and Shayne. So following on from previous discussions with David and Shayne, we're going to take a little bit of a different look at it. So looking at where the rubber meets the road, so to speak. So let's look, where's a good place to start? So let's start with the applicable standards. So the parking brake requirements are contained in, for heavy vehicles, contained in ADR 35 and 38. So 35 applying to your prime mover or truck, and 38 to your trailing equipment. Both of those were set the standards that our parking brakes need to meet. So at the moment, it's set at 18% grade. So what does that actually mean? So typically, like an 18% grade is about a 10-11 degree slope. So we're looking at holding the vehicle at whatever it's loaded to on that type of slope. One thing to note, that when we go through this ADR process, it's at the manufacturer's nominated GVM that it's tested to. And this often exceeds the maximum registrable GVM, and in some cases by quite a margin. But do you really understand what these standards represent? If we look at ADR 35 and 38, it probably doesn't mean a lot to most of us. So remember, compliance with the standards isn't the whole story. So let's look at ADR 35 and 38. So the ones that affect the operator the most are probably the performance requirements. So the vehicle, as said before, must meet a series of performance tests. There's test conditions. So looking on this slide, like there's temperature constraints. In Australia, like most operators would probably laugh at the temperature range. Like we're quite often operating outside those. So what does that mean for our braking systems? The tyres fitted to the vehicle must be of the size and type specified by the vehicle manufacturer. So after we get the vehicle, do we maintain that or do we put something else on? The friction elements, so our braking systems, again, must be the make and grade specified by the vehicle manufacturer, and that's specifically laid out in ADR 35 and 38. But again, are we maintaining it to that same level? When we do a brake reline, are we using OEM parts or are we using something else? Does that necessarily mean that our parking brake systems are going to meet the same performance standards? As I said before, it's at the moment, the test is conducted on a gradient of at least 18%. So what does a gradient mean? So that's simply the rise in meters over the horizontal distance. So when we're talking about an 18% grade, that doesn't mean an 18-degree slope. It's somewhere about 11 or 12 degrees in real terms. The test is laid out with requirements. So if you keep following through there's parts that don't really mean a lot to us. The test is for 5 minutes, which is okay. So if it doesn't move in the first 5 minutes, we hope it's not going to. And it's done in the forward and reverse direction. So that means if the truck's facing down a hill or up the hill, it doesn't really matter. But often we find in practice that the braking effect is actually different based on which direction you are, due to load up in the suspension and so forth. Once we go through that process, we know the combination meets the parking brake performance standards, but is that everything we need to worry about? We need to assess the available friction of the surface. So it's no good having a vehicle that's quite confident to be able to park on a 10-degree slope if there isn't enough friction on that slope to support that. So let's have a look at the different road surfaces. If we look at this table, dry concrete and asphalt has a peak friction value of about 0.8 to 0.9. Wet asphalt is significantly less, 0.5 to 0.7. Wet concrete, not too bad at 0.8. But then we get into some of the typical situations that affect particularly construction sites, working up in the forest, where we start getting into gravel and earth type friction areas, where gravel at only 0.6, wet earth at 0.5. So like we're nearly half of the available friction to be able to hold us on that hill or on that slope than what we had originally. If we get down even further, like 0.1 for ice. So when we're getting to that level, we don't need a lot to go wrong before we start having problems. So we've got a large variation, but there's other factors that are involved with that as well. The contact area of our tyres with the ground, the imposed mass, which we'll come back to, which axles are actually braked, and the slope will obviously have a large effect. So on this next slide, we're looking at a vehicle. This is a site up at Mount Hotham. Some people have been skiing up there, might recognise it. The photo doesn't really do justice to the actual true slope, so that's sitting at about the maximum. But from an operator's view, we need to look at more than just forward and back. We need to look at the side slope as well. So we need a risk management process to assess that. So with our risk assessment, we need to look at what friction can the surface provide. Does it remain the same, or does it change with variables such as temperature or surface water? A good example of that is if you were on a slope and you had rain the night before and then sub-zero temperatures overnight, where you're working one day without a problem before, you may find yourself sliding down the slope the next day. So we need to assess and think about those things. So let's have a look at a case study. So this was an actual incident from a major concrete supplier. The night before, agitator was delivering to a site that required the vehicle to reverse up a very steep concrete driveway. The driveway, typical of construction sites, there was sand and other contaminants on it as well. But the vehicle went up without too many problems and delivered its concrete on site. However, the concrete delivered was not all the mix in the agitator, so he had multiple deliveries. So the operator returned the agitator to the normal direction. And so once he did that, the remaining concrete moved forward into the agitator. As a result, the weight was transferred forward, unloaded the rear drive group, and that was the group that had the parking brakes on it, and it lost traction, was just relying on a greatly reduced amount of friction. Vehicle ran down the driveway, gained momentum, it started to veer into an uncontrolled turn and continued on, missing a home by only a few feet. That vehicle was well maintained. It was an ADR approved vehicle. Hazard assessment had been completed. The narrow driveway was identified as limiting, but other actions were taken to overcome those. The vehicle didn't have any problems getting up there. So you'd think everything was all good. So from that, they learnt, even if the driveway incline with the ADR parking requirements of 18%, the incident mightn't have been prevented. Typically, the manufacturer's GVM exceeds the maximum registrable GVM. So there was excess capacity there. So you would think it should be still okay. But now, as a result of that, the operators learned it requires their agitators to have parking brakes on at least one of the steer axles, as well as at least 50% of the rear axles. So when you've got that transfer of weight, you're not losing all the available friction to stop that vehicle going down the hill. So to give you an example of this, found this video on YouTube. It's just a suburban street, a small truck, as they call it over in the US. He's just backed out of his driveway like he's done 1,000 times before. And then he finds himself sliding down the hill. So something had changed overnight, and the vehicle, even though it meets all the requirements, like had no hope at all. He's just slid slowly down the street. So you can see in the video, he's obviously panicking a bit. He's gone for the lights, he's gone for the brakes and everything else. But there was no avail. The available friction just didn't meet what was required. So what are we going to learn from this? We need to know our vehicle. Where does your braking come from? Is it the same for all axle groups? Do we create a work plan? It may mean that the loads that we have on are removed in a particular order or adjusted on site for multiple deliveries. And we need to actively assess the risks. Don't assume similar sites are the same. So as you can see on the two photos I've indicated there, one where we're operating on gravel, we're unloading from the centre of both the trailer and truck and moving towards the back. So we've got that available friction is still there for the mass of the vehicle. And that's completely different to the one on the right, where we're on a much higher friction environment, so a dry asphalt. So think about those things and stay safe. Back to you, Bob. Thank you.
Thanks, Craig. Well, it's obvious that even with compliant technologies and processes, and assuming that a JHA was completed, it seems that some of the obvious hazards can still be missed. These are prime examples of how we can learn from the mistakes of others. Thank you to David, to Shayne and to Craig for the time taken to prepare your excellent presentations and your participation in TMC 2021. Shayne and Craig are part of the ITC team. By becoming an ITC member, you will get the opportunity to meet and converse with members with lots of technical and practical resources. Thanks to Emily for keeping us organised. The discussion from this session will be referenced in current review of the parking brake technical advisory procedures, and delegates are invited to direct your comments and questions via the comment box. Thank you all.